Hi, welcome to class. My name is Don LaFawn, Professor Don, and this class in Cisco 2 Module 3, we learn about VLANs. Next week, we also learn about inner VLAN routing. This week, we talk about VLANs within a single network. Next week, we'll find out how VLANs can work outside of the network, how a router routes VLANs. So we separated into two concepts, not too hard. Our presentation should be about an hour or so, and I'm going to get started right now. If you have any questions, any concerns at all about the content, and you're with me, hold those questions to the end of the presentation. If I don't cover the questions, then you can, we'll have a Q&A at that point. If you're watching this as a recording, of course, ask your questions inside of the help discussion forums, and your fellow students and I will help you understand the content. Let me go ahead and share my screen. Okay, you should see my screen now. And I am going to drag, I guess I could leave that there now because of the way I have it set up. Yep. All right then, so we're going to talk about VLANs. And specifically, we're going to explain the purpose of VLANs in a switch network. I'll explain how a switch forwards frames based on VLAN configuration in a multi-switch environment. We'll configure a switch to be assigned to a VLAN based on system requirements, your requirements as a technician. We'll configure a trunk port on a LAN switch, and we'll configure a dynamic trunking protocol. Overview of a VLAN. So virtual LANs, that's what VLAN stands for, virtual LAN, provide segmentation and organization flexibility in a switch network. VLANs are based on logical connections instead of physical connections. Placing devices into various VLANs has the following characteristics. It provides segmentation of various groups of devices, often with the same name, often on the same switch. It provides organization that is more manageable. Broadcast, multicast, and unicast are isolated in the individual VLANs. Each VLAN will have its own unique range of IP addressing, and you end up with smaller broadcast domains. So let me just open this, zoom in on this picture here, and we'll talk a little bit about VLANs. So if you didn't have VLANs, each set of computers would be connected to one switch on one router leg, and that would become its broadcast network. Literally, if in a classroom environment, say at a college, every student's computer would be connected to in a classroom would be connected to a switch that would be managed, that would have an interface on a router. And those computers would be able to talk to themselves, but they wouldn't be able to talk to anyone else. And all of the computers would have to be connected to the same switch. Otherwise, to be in a different network, you would have to have a different connection to the router. You would have to have maybe multiple switches for your classroom, for the teacher to have administrative access or faculty access to a different network, and the students would have their network. Well, you'd have to have two different networks in each classroom, two routers, two router connections, maybe one switch and then one single connection to the router, but you'd have to have that second port. Anyways, it would become complicated. You would have to have more wiring. Instead of controlling which network which VLAN segmenting networks, you could have the computer connected to the switch and via the same port for the instructor, for example, but yet that instructor has complete different access. Here, you could, here in IT, for example, you have everyone on VLAN 2, even though they're on 3 different floors of this building. Here, we have people that can communicate between each other, even though they're on different switches in different floors of the building. Same thing with VLAN 4. Sales cannot see, they can't even see HR. HR can't talk to IT without going all the way out to the router and then coming back. So we will learn, and then they can communicate. So if the traffic, if your traffic truly is going from VLAN 3 HR on this address to this address, if it's going from here to here, literally it has to go all the way out to the router and then come back, because these two are isolated. The two VLANs are isolated. The two VLANs are isolated. That's just a little introduction. We'll talk much more about that over the next few slides. So let me click here to go to the next slide. To go to the next slide. Can we go to the next slide? Ah, my computer is frozen completely. I am frozen. Hello. Can somebody say something if they can hear me?
You're coming in fine, Professor Don.
But I can't see my screen, so I'm going to stop. I can't even stop sharing. So you can hear me. I'm going to have to reboot. So everybody just sit still. I don't know if you're all going to get kicked out or not. If you do, just sign back in again, all right? Yeah, I got to reboot. Can you guys still hear me?
Yes, sir.
All right. System interrupts very high. Cisco services eating up 17%. Everything. All right. It's good. It's good again. All right. I don't know what just happened, but my computer. I apologize. Skip ahead. No. I'll continue the presentation. I turned on a fan on my computer to blow on my computer. Let's see if that makes a difference. All right, I'm not going to start it again. Don't worry. Let's continue with the presentation. So I read all of that. Okay. A VLAN is a logical partition of a layer 2 network. Multiple partitions can be created and multiple VLANs can coexist. The partitioning of a layer 2 network takes place inside a layer 2 device, usually via a switch. Each VLAN is a broadcast domain that can span multiple physical LAN segments. Hosts on the same VLAN are unaware of the VLAN's existence. VLANs are mutually isolated and packets can only pass between VLANs via a router. That backs up what I said. They also add that hosts on the same VLAN are unaware of the VLAN existence. All of these hosts, right? All of these hosts, they do not know they're in a VLAN. You don't do any configuration for the VLAN on the hosts. All of the configuration is done on a switch from today's presentation. That's where it's done, between switches. And then we'll learn next week that there's configuration on the router as well. So don't try to be configuring a VLAN on the hosts. No configuration over here. It's all done on the switches and ultimately on the router as well. The benefits of using VLANs are as follows. smaller broadcast domains. You dividing the VLAN in the LAN into several VLANs reduces the number of broadcast domains. It improves security. Only users in the same VLAN can communicate together. Like I said earlier, HR can't read and see packets of information from the IT department. Improved IT efficiency. VLANs can group devices with similar requirements, for example, faculty versus students, or I would say in addition to students. So in a classroom, you can have a VLAN that's faculty can access and a VLAN that students access. Reduce cost. One switch can support multiple groups of VLANs. Oh, that's true. I didn't mention that earlier, but you don't need multiple switches to have multiple VLANs. You configure which VLAN the host is on, whatever's plugged into that port, on the switch port itself. So you don't need more than one switch. You can have a single VLAN with say VLANs 10, 20, and 30 all on the same switch. So you can have one switch instead of having 3 different switches for each different network. Better performance, smaller broadcast domains reduce traffic, improving bandwidth, and simpler management. Similar groups will need similar applications and other network resources and access to system resources. Here we have an example where VLAN 10 can talk to VLAN 10, even though it's on another switch, possibly in a different network. VLAN 20 can talk to VLAN 20, but they can't. VLAN 20 here can't see VLAN 10 or VLAN 30. Sounds like my dog is getting yelled at. What is going on here? Why? All right, I'm not going to zoom in on anything anymore because it looks like it freezes my video for some reason. Yeah, not going to zoom in on anything anymore because right now I am stuck again. So I apologize for the technical issues. I might have to re-record this video because this is going to look bad in the actual recording. If you can hear me and I'm not doing anything right now in the recording, just skip ahead to where I'm talking again because I've got to wait for this system to come back on. I don't even know how I got it to do that last time. So WebEx is causing the problem. All right, so for some reason, WebEx doesn't like me zooming in, so I will not zoom in anymore, okay? Now, there's several different types of VLANs. The common types of VLANs include the default VLAN. Now, VLAN 1, everything is on VLAN 1 when you first turn on a switch. The default is VLAN 1. Now, in a perfect world, everything will be taken off of VLAN 1 by the time you are done configuring your switch. And even to the point where you could have a garbage VLAN that you put, or not used VLAN that you put all of the ports that are not in a different VLAN into the garbage VLAN or the not used VLAN. So to take it out of VLAN 1, that will actually improve VLAN 1 because even with no ports in VLAN 1 has all of the command and control features. Whether the routers are chattering back and forth, that happens using OSPF, EIGRP. That happens in VLAN 1 communication for all of the CMP ping, all of that's in VLAN 1. So leave it there. Well, you can't move it. All of that command chatter that happens between devices, that happens in VLAN 1. Take everything out of VLAN that you can, which includes all of your ports. The data VLAN, that's any VLAN that's commonly connected to a host computer. It carries generated traffic. Then there's the native VLAN. This is the VLAN that carries all untagged traffic. This is traffic that does not originate from a VLAN port. The native VLAN is VLAN 1 by default, but it should be changed for security reasons. And untagged traffic could be something like a legacy device, such as maybe, I don't know if a printer sends information that way. But if you had a hub connected, one of the old hubs, it would be untagged traffic. Anything connected to the hub would be untagged. Management VLAN, this is a VLAN that is created to carry network management traffic, including SSH, SMTP, syslog, and more. VLAN 1 is the default VLAN used for network management, but this also can be changed, and you name it management. As you can, I'm not going to zoom in, but you can see in the picture here that the default one VLAN has all of the ports that are in the system. Now you'll also see that there are 4 other ports. I'm getting ahead of myself. I know this information is coming up. Those ports are legacy. They're not used anymore, unsupported, but you can't get rid of them and you can't use them. And 1 is the default, so that leaves the number. So you can use VLANs 2 through 1001, which is 999 VLANs. There's some extended range VLANs we'll talk about later, but that's the normal range of VLANs. Now, to support time-sensitive traffic, Cisco switches support a voice VLAN that requires assured bandwidth, that means it's guaranteed, delay of less than 150 milliseconds across the network to ensure voice quality, transmission priority over other types of network traffic like web pages and the like, and the ability to be routed around congested areas on the network. So as you can see, we have a PC and a phone on the same connection. Now, I mentioned this last week, I believe, where I told you it is possible to have 2 different networks, one for the phone, one for the PC on the same connection. And this is how you do it. You put it in its own VLAN, but yet it's on the same port. We'll come back to that, don't worry. The voice VLAN feature enables access ports to carry user and IP voice traffic on the same line. In the figure, the Switch 3's F018 interface has been configured to tag traffic, student traffic on V20, and voice traffic on V150. Now, it doesn't have to be 150. It can be anything you want it to be. But 150 is what is used in the training program CCNA. The interface, F03, must be configured as voice and switch port voice VLAN 150. And this is the command that you use to allow the phone traffic to be on the same VLAN, or to be able to be used as phone traffic. Voice over IP traffic. Now, I want you guys to write that command down because I'm not sure that the instructions that are in the lab have that command, or at least it's not obvious. I've had students complain that that command was nowhere to be found. It's MLS QoS trust COS, and that is the script that configures, this information here: assured bandwidth, delay of less than 150, priority. That is what that command does. You can Google it, but it's beyond the scope of this class, and it doesn't really help to throw out all of that information. But know that you have to have that command on the port if you're going to have phone traffic and something else. You're going to do a lab for who hears the broadcast. For this lab 314 packet tracer, you do not have to give me the packet tracer file because it's not graded. You just have to give me the answers from the PDF that you will fill out as you do the lab. VLANs in a multi-switched environment. If a switch port receives a broadcast frame, it forwards it out all ports except for the originating port. Eventually, the entire network receives the broadcast because the broadcast is one broadcast domain. Without VLANs, all devices connected to a switch will receive all unicast, multicast, and broadcast traffic, as you can see in the display. VLANs can be used to limit the reach of broadcast frames because each VLAN is a broadcast domain. VLANs help control the reach of broadcast frames and their impact in the network. With VLANs, unicast, multicast, and broadcast traffic is confined to a VLAN. Without the layer 3 device to connect the VLANs, devices in different VLANs would not be able to communicate. You need to have, in this case, you would have to have a router up here so that the traffic going from VLAN 10 to VLAN 20 would actually go all the way out to the router and then come all the way back to get to VLAN 10. I'm jumping ahead to next week. Defining VLAN trunks. Now, a trunk is a point-to-point link between two network devices. Cisco trunk functions. They allow more than one VLAN to transfer over the connection. They extend the VLAN across the entire network. By default, they support all VLANs, and they support 802.1q trunking. There's another trunking mechanism, but we use 802.1q, and that's the only thing that's taught in this class. So you can go learn about the other method if you want. In order for where you would have a connection is right here between these two devices, because you need VLAN 10, VLAN 20, and VLAN 30 to transverse this connection. So this is called an access port. This is an access port. This is an access port. An access port leads to a host device. Only one, unless you have what we talked about earlier with the voice VLAN and needing that second command, the MOS QoS command, you can only have one VLAN on a connection. The exception is with voice over VLAN, voice over IP. But this port, it has to connect 10, 20, and 30. It has to let all three of them go across this connection. And so this side and this side both have to be configured to be a trunk port, and we'll get to that momentarily. Think about a trunk port as the trunk of a tree that's bringing lots of nutrients from lots of roots, the roots through the trunk to the branches, right? And you can understand how that trunk has to communicate with multiple roots, hosts, to get to the other hosts or the leaves on a tree. Tagging, Ethernet frames for VLAN identification. Tagging is added to the message. Before a frame is forwarded across a trunk link, it must be tagged with its VLAN information. Frame tagging is the process of adding a VLAN identification header to a frame. It is used to properly transmit multiple VLAN frames through the trunk. IEEE 802.1q is a very popular VLAN trunking protocol that defines the structure of the tagged header added to the frame. Switches add VLAN tagged information. Here's in this spot, and this is what the tag looks like. In this spot, we have the fields in the 802.1q tag include the VLAN ID, here's the VLAN ID. And it's 12 bits, 4096. That allows for 4096 VLANs. Now, I told you a moment ago there's 999 normal range VLANs, and then there's 4 that are unused but are restricted. That leaves 105, I believe 105 to 4095. We'll see it on another slide. VLANs for the extended range, and we'll talk about that later. Trunk links add the tag information before sending the frame, and then remove the tag before forwarding frames through the trunk port. So this information, including type, priority, CFI, and bit, and the actual VLAN ID are added as a tag to the command, as to the instruction as it's passed through. Now, the header is 4 bytes, and it includes when the tag and that tag is added on one side, it's removed on the other. When the tag is created by FCS, it must be recalculated. No, the frame check sequence must be recalculated. Here's the frame check sequence, because we're adding more information to our packet that's being, or our frame that's being sent. So we have to recalculate the FCS so that it's not identified as a giant or just as bad information, collision, packet that has collision, because if FCS wouldn't be correct. When sent to end devices, the tag must be removed and the FCS recalculated back to its original number. Now, the first portion, the function, is the type. It's referred to as the tag protocol ID, and it 2-byte Ethernet field is hexadecimal. For example, IPv4 is 0 times 8100. And it's easy to remember if you can remember the 8100. This 100 is 4. If it was IPv6, then this would be 110 for the number 6. User priority, 3-bit value that indicates a priority, range 0 to 7. Larger is a higher priority. The CFI. Canonical. The canonical format identifier is a 1-bit value that can support token ring frames. It's not used anymore. And that's why I always forget what that is. And then the VLAN ID, that tells you exactly which one of the VLANs. And again, it's 1 through 4096. Now, native VLANs and 802.1q tagging. Here are the basics. So tagging is typically done on all VLANs. The use of native VLAN was originally designed for legacy use, like hubs in this example. This is a hub, and because it was a hub, we used the native VLAN for untagged traffic so that the information can still get to the destination. Unless changed, VLAN 1 is the native VLAN. Both ends of the trunk link must be configured with the same native VLAN, and each trunk is configured separately, so it is possible to have a different native VLAN on separate trunks. And if there's no ports identified as a native VLAN, an untagged frame is dropped. So in this case, if we didn't have the native VLAN configured on PC1 and no configuration on the switch. So on these switches, these 5 switches, if we did not have a native VLAN, information from PC1 would not get to its destination. Voice VLAN tagging. The voice over IP phone is a 3-port switch. The switch will use CDP to inform the phone of voice VLAN. the phone will tag its own traffic, voice, and can set cost of service, COS. Cost of service is COS for layer 2. The phone may or may not tag frames from the PC. Normally I zoom in on this, but what they're saying here is the switch in the back of the phone, right? Here's the back of a phone. You have 3 ports in the back of your phone. Here is your the in from the network, and here is the out to the PC. So back to this picture again. The switch port configures will tag on this port. It'll be configured as I mentioned earlier with the QoS MOS command, and both VLANs 150 and VLAN 20 on that port right there on FO18, and then the switch will tag its traffic and send it to the out VLAN 150 back to the port, and it's good to go, right? Because both sides are configured for 150, you're good. The ASIC, remember ASIC is what makes a switch smart. Unlike a hub that doesn't have an ASIC, it's software driven. The ASIC will handle the switching mechanism to know which to send to the phone, which packets to send to the phone, and which packets to send out to the PC5. The Cisco IP phone contains those 3 ports I mentioned. Port 1 connects the switch to another voice over IP device. Port 2 is an internal 10100 interface that carries the IP phone traffic. And port 3 connects a PC. So this is the traffic that goes to and from the phone, and then PC3 comes here. And then if you have another switch or VoIP connection, you can connect it to the aux port. The link between switch and the IP phone behaves like a trunk to carry traffic from both VLANs, but the port is not configured as a trunk port. That's important to know that this port right here is not a trunk port. You would want it to be. You would think it should be because it's handling 2 different VLANs. It's handling 150 and in this case 20 VLAN 50 and 20. But this is not a trunk port. It is still an access port, and it remains an access port, and the phone handles the switching from 5 to PC5, VLANs 20 and 150. Voice VLAN verification example. So the show interfaces, we're going to look at that port, FO18 switch port command, is used to show us both data and voice VLANs assigned to the connection. Man, I normally zoom in, but I guess I'm not going to. You can see that VLAN 20 is configured and VLAN 150 is configured. And we're looking at show interfaces, and then you're looking at the actual port and then switch port. So that's the command. Show interfaces, whatever the port is, and then switch port. You're going to do a packet tracer where you're going to configure VLAN implementation. How do we do that? Well, let's go ahead and learn how to implement VLANs. So again, with the show VLAN brief command, you can see that all of the ports are all in VLAN 1. Our goal is to get it out of VLAN 1. And it's 105. So it's 1006. There's 4 of these. 1 to 1001, and then VLAN 6 to 4096. 4096 is not used. It is used, but you can't assign it. So it's really only to 4095. 4095. There's 4096 VLANs. Here they just say it. Let me just read it. So it's used in small to medium-sized business, used by service. That's normal range, 1 through 1005, but the last 4 are not used, remember. So it's really 1 through 1001. And then the extended range, 1006 to 4095, that's for extended range. They're used by service providers. 0 and 4095 is reserved. That can't be right. That's wrong. Hang on, I gotta fix this PowerPoint. I apologize for the delay here, but I want to fix this. Oh, it's a picture. I can't even fix it. Oh, so much for that. All right, we'll go back to the slide presentation. But it can't be, let's see. So no, that's, yeah. So, here, I can fix this. So, so if 0 and 4095 are reserved, then it has to be 4094. So this is 0 to 4095 is 4096 because you're counting 0. So that is 6. So if 0 and 4095 are reserved, then you can use 1 through 4094. All right, that's correct. Yes, I think it is. It can't be both, that 4095 is reserved and you can use 1 through 4094. Yeah, it doesn't make sense. And they are stored in the running configuration. So you must save them to your startup configuration. If you reboot otherwise when you reboot your switch, they will all go away. 1002 through 1005 are auto-created and cannot be deleted. You can't delete any of those. 1 is the default, and then 1002 through 1005 are legacy. They're stored in the VLAN.dat file in Flash. So if you save your running configuration to the startup configuration, your VLANs are going to be stored in the VLAN.dat file. And VTP is how you switches can send information between switches. And I'm not sure if we learned that in this class or not. We will. You'll hear VTP if we do. VTPs can synchronize between switches. It used to be in Cisco 3, but I think it might be in this class now. I'm not sure. We'll see in a little bit. The extended, but only in the lower range, 1 through 1005, 1006 through 4095 are not synchronized between switches. Well, that's interesting. I've never seen that happen before. Hello, what are you doing to me? One second, I'm going to pause the recording. So this is that same information put into a table. So again, 0 through 495, 0 and 495 are reserved, and you cannot see or use those VLANs. 1 is the default. 2 through 1001 you can use for normal operations, and VTP will share that information. 1002 through 1005 are defaults for fiber and token ring, and they are not used anymore, and you can't delete them. I don't know why. And then 1006 through 4094, and you can see that's the number I had to change on that other slide. Those are the extended VLANs, and they are used they are not shared by VTP. That's one of the important things. And I give you a link here to take you to another a portion in the classroom where you can learn about enabling it. But we'll see the commands here shortly. So VLAN details are stored in the VLAN.dat file. You create VLANs in the global configuration mode. Enter global configuration mode with the command config T. Create a VLAN with the valid ID number. VLAN and then whatever the number is, 20 for example. Then you give it a name, and then it would be student here. A uniquely named. Now you don't have to give it a name, but if you don't give it a name, when you go to look at all the VLANs, you'll have VLAN 20, 30, 40, 50, or whatever you want, and you won't remember what the name is, or you may not remember unless you have it written down someplace. So you're better off giving it a name as soon as you create the VLAN. And then return to privilege exec by end, and then enter global configuration mode. Now, this slide reminded me that VLANs are listed in the running configuration, but they are not stored in the startup configuration. VLANs are stored in the VLAN.dat file. So deleting the startup configuration does not delete the VLANs. They still exist. So you have to remember, if you want to completely wipe a switch, you need to remember to both delete the startup configuration and the VLAN.dat file. I mentioned it before, I had a class where we're learning RIP. We don't learn RIP anymore in Cisco, but we're at least at this level. And so we're learning RIP, and the entire class was doing it in person on real equipment, and we could not get, and nobody in the class could get RIP to run properly. And they rebooted switches, and they cleared the startup configuration file. But when I was new to teaching and I didn't know about that VLANs were stored in the VLAN.dat file, and what had happened, I found out when I asked another instructor that teaches Cisco here at my mentor, what could have been the problem. She goes, well, did you remember to delete the VLAN.dat file? I said, no. What's that, right? And she said, don't you remember that VLANs are stored on a switch in the VLAN.dat file? And I said, well, I'll never forget that again, because sure enough, when we deleted the next week when we got together, it took us 15 minutes to do the lab once we deleted that VLAN. And you're like, well, Don, why was it configured? Well, the class before me had been working with some configuration of VLANs, and they had set the VLANs to something that was not compatible with the RIP network that we were working with. So nobody was able to get it to work, but the next week it took 15 minutes. We were there till 15 minutes past 10 p.m. That was not, let's just say the students were very happy with me. But it's a learning lesson, you just got to learn, right? All right, so here is an example of it actually configuring. You can see on switch one, you go into config T, you create VLAN 20, you name it student, and you get out of it. Now, if you do not name it, the Cisco IOS will give it a default name of VLAN and the 4-digit number. So your name would be VLAN 0020 for VLAN 20. Again, not very helpful. Once a VLAN is created, we can then assign it to the correct interface. Now, again, we're creating the VLAN on. Why am I not getting it? I really don't understand. I don't have my tools because it's not putting me in the right mode. So anyways, I'll just use this. So we create the VLAN on the switch, but now we have to go into config T, and we have to go to interface ID, right? Yep, can't see it there. Interface, I'm sorry, we have to go into the interface, FO18, and then this is the command you have to type, switch port mode access. You're setting the switch port to an access port instead of a trunk port, which is what this will be if this port is going to transfer more than one type 1 VLAN. It must be configured in a trunk port to be able to share that information. So this will be a trunk port, that will be a trunk port, this will be an access port because it reaches out to a host device. And then you have to remember, not only do you, the first thing you do is you say switch port mode access. You're putting it into access mode, or conversely, a switch port mode trunk. Then if it's going to be a trunk port, then you put switch, then you have to assign it to the actual VLAN. So then that command is switch port access VLAN 10, if it was VLAN 10 or 20 or 30 or whatever, and then get out of it. So you have to make it an access port first, and then you have to, with the next command, you have to assign it a VLAN. Make it an access port by switch port mode access, and then assign the VLAN with switch port access VLAN 10. Okay. When we assign the VLAN to a switch port interface, recall there is no VLAN configuration on end devices. Nothing is configured here. Everything is configured on the switch. Once a port is assigned a VLAN, the end device must be assigned an IP address if it doesn't have one. So then you just go to PC2 and you go into configuration and you set the manually, or you have it set automatically. Now, they don't actually show you the commands here. That's the same command that was on the previous page. Now, if you do not, if you do not have the VLAN that you assign in VLAN 20, if you haven't remembered to create VLAN 20 and give it a name, student, you can still use this command, switch port mode access, switch port access VLAN 20. If it doesn't exist, then what will happen is you'll get this message, and it's not an error message. It says access VLAN does not exist, creating VLAN 30 in this case. I don't know why. Let's say 20. And that will create the VLAN, but it will be named VLAN 20, VLAN 0020. It won't have student. So then you can go back in and you can rename the VLAN. Data and voice VLANs. So recall that an access port may only be assigned one data VLAN. However, it may also be assigned to one voice VLAN for when a phone and an end device are on the same network. On this port, both voice traffic to the IP and data traffic to PC5 will be passed. And this is the command to do that. So we'll want to create and name both VLANs first, the voice VLAN and the data VLAN. In addition to assigning the data VLAN, we will also assign the voice VLAN and turn on QoS for the voice traffic on the interface. The newer Catalyst switch will automatically create the VLAN if it does not already exist when assigned to an interface, as I showed you a couple slides ago, but it won't give it a name. Now, QoS is beyond the scope of this course. Here, we do show the use of MLS, QoS, trust, and then whether or not it's COS or device, and then or device Cisco phone, and DSP or IC precedence. That is the whole command. What we use is MLS QRS trust COS. You need to remember that command. Again, hopefully you have all written it down. So when you get to dealing with voice VLANs, you don't have to search the internet to find it. They may have added it to the content now, but they didn't have it when I went through the course. And it was a lot of students struggled back then when I first started teaching. But again, create the VLAN, VLAN 20, name it. Then the good news is you don't have to exit. If you have another VLAN to create, you just create the next one. VLAN 150, name it. If you had another one, VLAN 30, HR, whatever. When you're done creating all your VLANs, then exit. Then go into the interface that you are going to make an access port. And the first command is switch port mode access. And that access is making the port an access port. Now you still have to assign that port to a VLAN. So the next command is switch port access VLAN 20. And if you forget this command here with switch port access, like you can even if you forget the mode, right? Like, oh man, I know it's a switch port. I don't remember the commands. You can do switch port ? But don't get confused and then go into access and then try to do something with access. You got to set the mode first. You have to make it an access port or a trunk port. Then do the ? again. Then you'll see access, and then you'll say, oh, I wonder what's next. A ? Oh, VLAN. Oh, yeah, I got the 20. And then off you go. The next command, MLS QRS trust, you can't do that. You can't do a ? to find MLS. The chances are you doing a ? with all the commands in the Cisco switch. And finding MLS are pretty slim. So you really need to know at least that first part, the MLS, when you're going through the command structure for setting the voice over IP command. Now, to verify VLAN information, use the show VLAN command. The complete syntax is show VLAN. Now you can do brief and it'll give you all of the interface information. You can put in a VLAN ID, so you can say show VLAN 20. You can put a name in there, show VLAN name. I've never done that before. And then the name itself, so student, for example. And then, or you can do a VLAN summary. So most of the time, you're going to do show VLAN summary or show VLAN. Show VLAN, of course, gives you all of the information. Summary gives you how many VLANs there are and how many extended, whether they're extended or normal range. Show interface VLAN gives you information about that VLAN that you specifically are talking about. Show VLAN brief will give you the names of the VLAN, the statuses of them, and what ports are on the VLANs. You'll do a show VLAN brief many times. Show information about a specific one is show VLAN show VLAN ID, and then whatever it is, it'll give you information. Then I don't think you put the ID in there. You just say show VLAN 20 or show VLAN and the name itself, and then summary if you want what I showed you above. Now, changing VLAN port membership properly. Now, the best way to do it, or the way you have to do it, is you have to remove the ports from a VLAN before you delete the VLAN. You have to. If you don't, if you just delete the VLAN, then you're going to have a problem because the VLAN will just disappear from the list of VLANs. So first of all, you should remove the VLANs from the port before you delete the VLAN. So in this case, configure terminal interface FO18, no switch port access VLAN, and that VLAN 20 or whatever. Well, it's already assigned. You don't need the 20. I think you could put the 20 in there anyways. It doesn't matter. And then N to get out of it. And then it would put it back into VLAN 1. You can see we moved VLAN 18 before to a different it was in VLAN 20. Now VLAN 20 doesn't have any VLAN 20 doesn't have any ports in it, and FO18 is back under 1. Now, if I don't know if it, yeah, I'll come back to it. Show interface FO18 switch port will show command to verify the correct VLAN associated and detailed information. So here it's showing that it has, actually it's showing that there's no VLAN on this because it's still in access mode, but there's no, oh no, it's in VLAN, I'm sorry, it's in VLAN 1. It's no longer in the VLAN that you put it in earlier, which was 18. Okay, so here, config T, no VLAN 20 set removes the VLAN. Now, here's where the trick is. It's not a trick, it's a problem. Is if you delete your VLAN 20 when it still has ports in it. Let's say we wanted to get rid of VLAN 20. Well, those are the commands to get rid of it. But remember earlier we removed port 20, FO18 from VLAN 20. Then that put it back into default VLAN 1. If you do not remove all the ports from the VLAN before you delete the VLAN, shown here, then those ports will disappear. They will disappear. They will not exist anymore. And since you deleted the VLAN, you will not know what VLAN it was in unless you remember, right? So if I said VLAN 175 and then I figure out what was that VLAN I was in, you have a problem. Now, you don't have to go looking for the VLAN. You can just assign it to a different VLAN. So if you're missing, say, port 18, because it was in VLAN 20, you can go to port 20 and you can assign VLAN 18, go to port 18, FA18, and assign it to a different VLAN. That will bring it out of ghost mode. I'll call it ghost mode. I don't think it's called ghost mode, but it still exists, but it's not, and that port will not work. So because it's part of a VLAN that no longer exists, that will be, I think, one of the troubleshooting things we do in this class before you end the class. They will have deleted a VLAN where there was a port in it. And the only way to really notice it is to go through and look. Well, what do I have? I have one. What do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm missing 18. Oh, that's why 18 isn't in VLAN 1. It's in another VLAN. Well, then now you just need to go and assign VLAN. You can either create VLAN 20 and the port will show back up again, or you have to just assign port 18 to another VLAN. VLAN 1. You can assign it to VLAN 1 and it will pop back in and you'll see it again. Now, I said this already, you can delete all VLANs with the delete flash :VLAN.dat. Now, you do not have to do that in this class because we are meeting virtually. The packet traces are all set unless they're actually having you do that command. You do not need to do that command before you start a packet tracer. And the NetLab assignments, unless, again, it tells you to do it, there's no need to do it. But that's the command to remove it. Now, it's delete flash :VLAN.dat. If you flash is the default, so you can actually just use delete VLAN.dat and it will go to flash and delete it. But if your VLAN was maybe stored on a USB drive or something, I don't know, you can delete that DAT file. If you have backup and you want to delete the backup, you have to identify it flash 01 :VLAN.dat and then delete it. And then you need to reload the switch to delete all the VLANs. To restore to factory default, unplug all the cables, erase the startup configuration, and that doesn't seem like, oh, not all the cables, leave the power plugged in. Unplug all the data cables, all of your RJ45 cables going to other devices, and then erase the startup configuration and delete the VLAN.dat file, then reload the device and it will be completely clear. That's what we should have done. That's what we began doing in every single lab. I think it's even shown on this lab when we get to it. Yeah. And I have this is I went online to find this information someplace, and I found it in a Google Doc, and there was no way I could figure out how to get to this page without the highlighted text, without buying that document. Yawn. Don't want to yawn in front of you, otherwise I'd have 18 students yawning right now. Anyways, caution, and this is what I said a moment ago. Before deleting a VLAN, be sure to first reassign all member ports to a different VLAN. Any ports that are not moved to an active VLAN are unable to communicate with other hosts after the VLAN is deleted and until they are reassigned to an active VLAN. Alternatively, the entire VLAN.dat file, basically deleting all of the VLANs, can be deleted using the delete flash :VLAN.dat privilege exec command. The abbreviated command is just delete VLAN.dat. It can be used if the VLAN.dat file has not been moved from its default location. After issuing the command and reloading the switch, the previously configured VLANs will no longer be present. This effectively places the switch into factory default conditions concerning VLAN configurations. You are going to do a packet tracer, packet tracer 3.3.12, and it's going to verify default VLAN configuration. And I don't show you the commands. Wow, that's pretty cool that it didn't. I don't know why it didn't show you the commands. That's so weird. It's like I'm showing two different presentations. It's not hidden, but for some reason, it is hidden. All right, we're going to learn trunks. Now we've configured how to get a switch to talk to an individual host on an access port. The next thing we have to learn is how to configure our trunk ports so that we can get multiple VLANs to communicate between switches. So the command to configure and verify VLAN trunks. Remember, trunks are layer 2. They talk between switches. So you do not configure these commands. You do not configure this on the router. You only do it on the switch. Trunks are only, yes, you will be talking from a switch to a router, and you will configure the switch side with these commands. But then there's other commands that we'll learn how to configure when we get to the router side. The command, first you enter global config mode, config T, you go to the interface, and then now remember before we did switchboard mode access, now we do switchboard mode trunk. And there's two commands that you have, really. The next command is, remember you have to have a native VLAN for untagged traffic to communicate. So that's switchboard trunk, and then do a question mark if you forget. So switchboard mode trunk and switchboard trunk. Before we did switchboard mode access, switchboard access. So switchboard trunk, native VLAN 10, 80, whatever. And and then you will immediately start getting error messages because if you're connected to another switch, because now you will have a different native VLAN than the other switch. The other switch will probably still be in VLAN 1, and you'll be in VLAN 30 or whatever. And you need to just go to the other side and configure the other side. Now, the next step is to say which which VLANs are allowed to communicate across that trunk. Now, if you do not do this command, it will still work, but your trunk will still pass traffic, but it'll pass all traffic. So if you have, for example, somebody breaking into your system and they're connecting their switch to your switch to be able to communicate with your routers, then they will be allowed. They'll just put themselves on a VLAN and they'll be off and running on your network. So you need to allow only, say, 10, 20, 30. If those are the only VLANs that you are allowing that you've configured, those should be the only VLANs that are allowed to transfer across that VLAN. And then end out of that. So again, switchboard mode trunk, you're making the port a trunk port. You only configure switchboard mode trunk and these other commands on the trunk, on a switch that goes from a switch to a switch, or the switch side of the connection to a router. Okay? You do not use these commands on a router. The router has its own commands, but you do have to, on the switch side of your connection to a router, you do have to use these commands because you're still controlling what VLANs are allowed to go out of the switch and the fact that it is a trunk. But on the switch, on the router side, it has its own commands. Now, here's an example. So the subnets associated with each VLAN, VLAN 10 is the 10 network, VLAN 20 is the 20 network, VLAN 30 is the 30 network, faculty, students, guests, and then we have our native VLAN 99, and it's the 99 network. You know how that is. And now we need to go into this port right here on FO1. That's the port that we are configuring our trunk right here. These are not trunk ports. Those are access ports because they go to host devices. This is the trunk. That's a trunk. So you have to do FO1 on S2 and FO1 on S1. And the commands are, you go to the interface and you type switchboard mode trunk. You put the native VLAN on it so you don't forget. Do that first. So switchboard trunk, native VLAN 99. And then what VLANs are allowed? In this case, 10, 20, 30. And of course, don't forget to allow your native VLAN to transverse across that trunk as well. And then you can verify that command by going to your do a show interfaces FAO1 and the command is interface FAO1, and then you can see it is a trunk mode, and in this case you're allowing all trunks, and it does say that it's VLAN 99. And that trunking encapsulation .1Q, that actually comes into play next week when we, are you ahead of me or am I ahead? Here, I might be ahead of you. Wow. No, that's the right one. Why does mine look different? Oh, I'm ahead of you? Hold on. I must be ahead of you. Yeah, I'm ahead of you. We will see the tagging. The tagging is .1Q, and we will use that .1Q next week when we meet and we discuss the VLAN. Now notice they created VLAN 99, and look at the name of VLAN 0099. So most likely the person that created this slide forgot to name his native VLAN when he was naming his other VLANs. He forgot to name the native one. So when he assigned the VLAN to the port, the system created the name VLAN 99. And because there is, you see here, it's going to send everything because there's no just ports that are configured. I mean, you don't see where it says 10, 20, 30, 99. And reset to default trunk settings with the no command. So if you want to take it out of trunk mode, it's no switchboard trunk mode, and then you will have, then it'll be in access mode after you take it out of trunk mode. So here you can see you took it out of trunk mode and that put it back into access mode. And then reset to an access pose is static access, and that removes the trunk feature. And you're going to do a packet tracer on that. And let's see here. Yep, I did good. I actually hid the commands so you guys don't get them in your video. I did that before. That's awesome. You're also going to do NetLab 3.4.6, configuring VLANs and trunks, and you'll build a network. You'll actually build the network, set the device settings, assign the switchboards, and you, at the beginning, check for existing VLANs. You definitely need to do this on real equipment, but just so you can see how it looks at the beginning, go ahead and look at your VLANs. Ensure the switches have been erased and no startup configuration of VLAN information exists. Just check, okay? At the conclusion, go ahead and delete the startup config, erase the startup config. That's the command, erase startup config. And you can either use delete VLAN.dat or delete flash :VLAN.dat. Or you can just erase NVRAM and it erases everything. Now this, you would not want to do this on a packet tracer, especially the erase everything. I don't know if it affects your points. I suspect it would. But remember in NetLab, I go look at your commands. So I want you to, I won't look, but check for it and take off points for it. But I should actually see that at the very end of your NetLab, even though it doesn't say it. Those of you that are paying attention and are still awake, you will have, I will see that command erasing it at the very end. And you'll do another NetLab on 3.4.6, configure VLAN trunks. Dynamic trunking protocol. Now, that's DTP, right? Like I said, I wasn't sure if they moved this to Cisco 2. They do. Now, dynamic trunking protocol is a protocol that lets switches automatically negotiate trunking with a neighbor device. This protocol is called dynamic trunking protocol. DTP can speed up configuration process for a network administrator. Ethernet trunk interfaces support different trunking modes. An interface can be set to trunking or non-trunking, or to negotiate trunking with a neighbor interface. DTP operates between switches on a point-to-point basis only. So these two switches are talking, these two switches are talking, these two switches are talking, and these two switches are talking. This is not sending information from an administrator out to the equipment. It's just setting up the equipment to automatically negotiate a trunk if, and I'll show you in a minute, if both sides are in negotiation mode. Now, the dynamic trunking protocol is a proprietary Cisco protocol. DTP characteristics are as follows. On by default on the Catalyst 2960 and 2950 switches. Dynamic auto is the default on those same switches. I will explain what that means in a couple minutes. It may be turned off with the non-negotiate command, which you would want to do on any port going to a host, for example. May be turned back on by setting the interface to dynamic auto. Setting a switch to static trunk or static access will avoid negotiation issues with the switchboard mode trunk or the switchboard mode access commands. Basically, you're forcing it to be trunk or an access port. And I'll show you a table that helps to understand this in a couple of minutes. So switchboard mode trunk, switchboard non-negotiate, you would want to set that to any port that you do not want any negotiation to happen on. Switchboard mode dynamic auto to set it to that command. Now, the switchboard mode command has additional options. Use switchboard non-negotiate interface to configure the command to stop DTP negotiation. But you can also use access to permit access mode and negotiates to convert the neighboring link to an access link. You can also do it to trunk, and that will permeate trunking mode and negotiate to convert a neighboring link to trunk mode, trunking. So you get access in trunk that forces it to access a trunk. Now, if the other side is not an access or trunk, if the other, I'll show you in a table, it's easier to understand. The other two are dynamic auto and dynamic desirable. Now, if you're in dynamic auto on one side, it will and access on the other, it will switch to access. It just automatically becomes whatever's on the other side. Dynamic auto, the other side's trunk, it'll become a trunk, no problem. But if you have two dynamic autos, they're just going to sit there. They are not going to communicate to each other. No connection will be made because nothing is forcing it to be one or the other. They're just kind of in the middle, all right? They'll just stay there too. Now, dynamic desirable, it actively seeks to become a trunk by negotiating with either auto or trunk or another desirable. Here, the table here will help you understand. So, where'd it go? Why'd it go? Okay, resume. All right, my PowerPoint just restarted for some strange reason, but this is the table that's going to help you to understand when to do what, okay? So it's really easy. So again, if you're in trunk and the other one's in auto, you're going to go to trunk. If you're in trunk, the other one's in desirable, well, it wants to be in trunk, so you're going to go to trunk. If you're in trunk and trunk, hey, you're good to go, you're a trunk, and it won't switch. It's never going to negotiate. You're a trunk line, because neither one of these negotiate. You are a trunk line. But if you're in trunk and the other one's in access, guess what? You're not communicating, all right? Same thing's true with access. Access and access, you're great. Access here and access here, you're great. It will be an access port, no negotiation. It will stick to access. Access with dynamic auto, you're great. Access with dynamic desirable, okay, it prefers to be a trunk, but it will be an access port. It's okay. It's like, if I have to be, I'd rather be a trunk, desirable, I'd rather be a trunk, but I'll be an access port if you want me to be. That's desirable and access, you get access. And then access and trunk, well, no, you're not going to get a communication there because it's two different types. And then the other one here, dynamic desirable and dynamic auto, this one desires to be a trunk, so you become a trunk. Dynamic desirable and dynamic desirable, you won't both want to be a trunk, you're a trunk, no problem. Dynamic desirable and a trunk, you're a trunk, and dynamic desirable and access, you're an access. It prefers to be a trunk. I just showed you the other way. So this, I don't think this is, let me look here. Hang on a second. Access, I want dynamic auto and dynamic auto. It should be whatever it's currently in, it will stay in. It will not negotiate. So I'm not certain that is absolutely correct. This should be limited connectivity. If they both happen to be access, it will work. But the one you have a problem with is a trunk and access or trunk and access. That's when you have a problem. And you also have a problem with it, both of them being in dynamic auto. And it's not showing me that on that slide. But here we have switchboard dynamic desirable and dynamic desirable, you are good. A trunk is not formed if it's dynamic auto and dynamic auto. A trunk is not formed, they'll remain in access, and it will just remain an access port. It will not become a trunk. I guess you would have communication over that connection for VLAN 1, for example, because both sides have a VLAN 1. Without a trunk, though, I don't know how it would communicate past that. For all the other VLANs, you need to have multiple. You need to have a trunk to pass multiple VLANs. Verifying DTP, the command is show DTP interface, and then whatever the interface you want, and you can say that it has if it's how many times that it has tried to become a how many times it's tried to become a trunk, if it's enabled, if any negotiate. You'll read through that. You'll do a lab, packet tracer 3.3.5, configuring DTP, and packet tracer 3.6.1. That is where you're going to implement the whole thing, and NetLab 362 implementing the entire thing. And we are done with our presentation for today. Man, I don't know if we could have had more technical problems than that in one presentation. So I'm happy to be at the end of the presentation, and just a little bit past 8 o'clock as I record this, and so I hopefully you got the best out of this presentation that I could have to offer you as we finish this thing up. So. If you have any questions, you probably have lots of questions. If you probably have lots of questions after that presentation. It was all technical. I have no idea why my computer froze twice with zooming in. That never happened before. But again, remember, I'm using that laptop, and I have two big screens connected to it through a hub. I highly recommend this company, by the way. Maybe I shouldn't, because I just ran into a bunch of problems. But QGM, this is a USB-C with all sorts of connections. There's 12 different connections on it. Maybe that's where the problem is. Maybe I need to not have all this stuff going. But anyways, if you have any questions, ask in the help discussion forum or in just a moment when I stop recording. Again, my name is Don LaFond, and it's been a pleasure stumbling through this presentation with you. I hope you enjoyed it more than I did. Thanks. Bye.